Thanks for the warm welcome. So before we start, let's have a quick survey, a quick one, since most of us are the web scrapers. So how many of us are the ones who thought we have written the best XPath or CSS selector, and exactly at the moment when you start relying on it, it betrayed and was broken by some front-end dude who was replacing div with a span or something. So by the raise of your hand, oh, I can see a lot of people. So I can feel the pain. Um, um, so, yeah, my name is Zia, and I'm working as a data scientist, as it is explained. So I'll try to address this issue, how data science and artificial intelligence can solve, or how it is solving this problem, and how this whole problem is shifting from how any particular thing needs to be done from just what needs to be done in this AI era. So we'll be talking about how machine learning works, how web scraping has helped machine learning or AI to be what it is right now, and how AI is trying to pay back to web scraping. We'll talk about some limitations, and we'll see how AI versus AI race going on. Um, Machine learning and web scraping, two very powerful fields, two very powerful domains. And just imagine if they both start collaborating and empowering each other, how the future will look like. Web scraping can provide a lot of oxygen in the form of data to artificial intelligence, and in return, AI can post a lot of intelligence to web scraping, and it can write intelligent scrapers and pretty much smart scrapers. But so far, this has been only a one-way affair where web scraping has been fueling AI with a lot of data, and AI was not doing much for web scraping so far. But in near past, we have seen that there are AI-based scraper that have been doing wonders nowadays. That comes to a question that whether AI is going to replace scrapers or not. We already have an answer in one of the previous discussions. So let's see how it works. Use case. So let's say we want to automate a pipeline where we are getting some data from any e-commerce website. We have a scraper which is feeding this data to AI, which is creating some analysis on this data, and then those analyses can be fed to the executives. Works great. Everyone is happy. But when that front-end dude is replacing devs with the spans, scraper breaks, and the whole loop actually breaks. And what is the solution to this thing? So we'll learn about that. That is the whole thing. That is the whole thing that we want to address today. How we can create this whole loop, and it should heal itself once the error is there. Um, so how artificial and how AI and human are linked together. By the way, have you ever wondered why it is called artificial intelligence, not the real one? I mean, the dude who invented this, okay, I invented this beautiful thing, but it is artificial. Does not make sense, because one of the reasons it takes inspiration from human who possess the real intelligence. Whenever you want to ask something, whenever you have a question about how AI is doing this thing, just try to learn how human will do any particular new task. For example, there's a kid who wants to learn about the difference between cats and dogs. How would you do that? You will take this kid to the park. You will say, hey, look, that's a dog. Kid will say, okay, fine. Anything with the four legs and a tail is going to be a dog. Fine. So you're actually supervising this kid by showing some data that, look, it's a dog. And this kid has enhanced its learning by getting some features out of it. Later on, kid will see a cat and he will say, look, it's a dog because it has four legs and a tail. But he will say, no, it's a cat. Now learning has been enhanced. New features have been added. Kid might say that, okay, fine, four legs and a tail always not works. Maybe the height also matters, and so on and so forth. So the more and more data you'll be feeding to this kid, the more and more learning will be enhanced. So we come to a point where we can establish the fact that quality and quantity of the data is directly proportional to the quality of learning, whether in human or AI. We know that any engineer with a 5-year experience generally considered better than someone with a 1-year experience. Why? Because this 5-year guy has consumed more data than the other guy. Same case with the AI. So if you're feeding good quality and quantity of data, it will work fine. Um, and that comes to a point. What kind of data AI consumes? It consumes only the digital data. Where do we find a lot of digital data? Arguably on web. So on web structure, we have the largest amount of digital data. Um, and if we have a lot of digital data on web, what is the best tool to scrape the data? Why do we need to scrape the data for AI? Because if we talk about any large language model that are doing wonders nowadays, we know that they have been trained on trillions of tokens. One token is roughly equal to one or sometimes 1.5 word. So, so we need to scrape a lot of data to fuel these models so that these models can answer our questions. Humanly generating this much data is nearly impossible or so much costly that one cannot easily bear the cost. So scraping has to be there. Scraping has been fueling these AI agents since the birth of the AI agents. So whether it is sentiment analysis, predictive analysis, competitive analysis, healthcare, live data, whatever it is, web scraping is fueling AI with the data. So that is something we have talked about that comes from the past. Why and how AI agents or AI models have been fueled so much. Why? Because they have been fueled by web scraping mostly. Obviously, the other data is also being used. So now, where do we go now? How machine learning is paying back to web scraping? So reiterating the problem was our scraper was getting broken uh, by the brittleness and all of the other things. So let's see how AI can fix this problem. There is a lot of research going on in this particular domain. I have listed only 3 proposed solutions that are working great nowadays, but there are other solutions as well. And you should expect more and more newer solution as if I'm speaking right now. Starting from the easiest one, and I'm sure all of you must have used this one, which is using pre-trained large language models like ChatGPT or Gemini or whatever. Simple. If you provide a screenshot, you write a very simple prompt, and it works perfectly fine, mostly, not always. So I just tried it before coming here, and yeah, at least for this one particular page, it got perfect data for me. But what if I want to do it on a large scale? Obviously, these 4 or 5 products are not good enough. So a pipeline can surely be created where you can take a lot of screenshots and you have a lot of people sitting and they're posting it on ChatGPT or whatever, and you'll be getting the results. Sounds pretty dumb, right? So another way, the workaround, is you can use the APIs. Easiest thing, you can automate this pipeline by writing a code that is taking the screenshots. So it is actually, you're not going to the classical web scraping way. You're not going to the DOM anymore. It blocks you. It does a lot of bad things to you as a scraper. So you're not going that way anymore. You're simply you're making use of the UI, taking screenshots, and using some API to get the data. Is it 100% accurate? No. You cannot 100% rely on AI so far. Um, so yeah, there are workarounds. Rather than asking AI to get you the data, you can ask AI to write the code for you to get the data. And I tried to do that, and I got interesting results. AI said, no, I cannot do that. Oh, sorry. I just posted the link. I said, just scrape the data from that link. And it said, no, I'm not going to do that. Fine, we have the workarounds. Then write code for me that will scrape the data. And it did. It did. It didn't work at the very first instance. So what did I do? I just copied and pasted the whole DOM object. And I said, OK, fix your selectors and XPath, and it worked. And if you're working on a smaller scale, um, whenever your scraper is broken, you don't have to look into the depth of DOM. Just copy and paste it on some LLM, and most of the times it will work. Easy and plug and play kind of a solution, but not very much scalable. Those who are working on a smaller scale or just for fun, it's a fun solution for you guys. Um, Now, talking about some serious solutions. Um, Again, we are not going to go towards the DOM. We will go shortly over there when we'll be talking about the third solution. Right now, we are talking about the second solution, which is using computer vision techniques. Again, screenshots are required, but this time, this solution is not going to use any third party at all. It is going to use your local processing, where you'll be training your own local model that will learn to locate the area in the screenshot where that interests you the most. For example, if I need the prices from the e-commerce website, I'll annotate the data, I'll train the model on that data. So I can use any CV models like maybe YOLO, RCNN, fast RCNN, and many more. I can transfer the model as well if I don't have much data. So I can use transfer learning as well using pre-trained models and just transfer it a little bit on your small data set. Okay, it works generally fine, but there's a limitation that computer vision models will not give you results in text. At max, it will highlight the interested area for you, but it will not give you the result exactly in text. So the solution is we can add one more object in this pipeline where if we are getting data from a website using object detection algorithms, that will get us the bounding boxes. And from these bounding boxes, we can use OCRs, optical character recognitions, to get our desired results. It worked. It works pretty much fine, but there are again some limitations to it. If the visuals of the websites got changed, I'm not talking about the DOM anymore. Again, if the visual structure has been changed a lot, you need some more training. If right now you have trained it on pricing, you need titles as well, you need reviews as well, you need some further training for that. So from scalability perspective, it might not work pretty much. But if you are working with some use case where you think structure might change, but the visuals won't change much, it works fine. And finally, the buzzword, the buzz thing that is there nowadays, which is called self-healing scrapers. That is using the old classical technique of scraping and putting AI on it and trying to create such scrapers. Whenever they're broken, they can self-heal themselves. How it works. Again, we have multiple techniques over here as well. DOM node classification that works like something like random forest or tree like a structure, but I'll be mainly talking about sequence models that we can use over here. So in short, what is a sequence model? We all have been using the search engines. So whenever we write something, it tries to predict the next word. How it do that? So let's say if I say, I like sushi a lot, which I don't. Um, so so my favorite cuisine is, and then if I just write is and stop, and then I let AI predict it, AI will use the context, the semantic analysis, and it will try to convert it into the tokens and all that painful pre-processing stuff goes on. But in short, it will make use of the context and it will see which is the most relevant word over here if you're using the attention models or something. And then let's say sushi is the most interesting word over here, then it will try to predict. So my favorite cuisine is Japanese. So that is how mostly sequence models are working. Fine. So if it can predict the next word based upon the previous sentence, and we have been using these applications for a long time, it can also predict my broken XPath as well. So let's say previously I have an XPath where div bracket 1 was there, which is replaced by div bracket 2 now. So if we pass that DOM object, and we don't do that manually every time, but if we have a pipeline where this DOM is passed to our sequence models every time it is broken, it will gain the context of the XPath that we have so far, and it has already been trained on a lot of DOM objects. So it will try to predict the next, and the next element in the XPath or CSS selector, and it works pretty much fine. So in the whole pipeline, whenever you detect scraper is broken, which can be easily detected, you just invoke this sequence model or DOM not classification model that will try to fix this XPath or CSS selector. And that usually works fine. So that comes to a point where now machine learning or AI has started fueling web scraping as well. That comes to a point where our use case is pretty much effective. So we have some data coming from e-learning, scraper is scraping, AI is analyzing, presenting the results. If it is broken, then AI will provide a feedback loop and it will try to fix the XPath or the CSS selectors by using multiple techniques that we have discussed so far. Nothing ends before talking about the elephant in the room, which is limitation. I know whenever we talk about AI, the very first thing, tell me about the accuracy, how much accurate it is. It is pretty much accurate, depends upon the different use cases, but how we can further enhance the accuracy, there are multiple ways. So one of the easiest way is you can use multiple models together and use the democratic values over here as well. And it is a very classical method. In machine learning, it is called bagging and boosting, where you use multiple models, you have the result, and you count which class has got maximum votes, and you go with that. Again, this will reduce the number of errors practically and theoretically, but it will not cut down the errors to 0%. Still, the chances of error are there. So this whole pipeline can reduce our workforce to a significant level, but so far, if you say it will totally replace the scrapers, I will surely disagree to that. But it will surely reduce the work power. Finally, arms race where AI is working as an offensive force and AI is working as a defensive force. So AI is as an anti-bot defense. AI is trying to detect whether the the mouse movement patterns are working fine or not, if it is very straight or vertical, or I know we don't move the mouse completely straight or vertical. So if these kind of patterns are there, so here is the CAPTCHA, solve it. On the other hand, AI is trying to emulate the human experience. So it adds randomness to the keystrokes. It adds randomness to the mouse movement and everything. And the one of the last layer of defenses for the defensive AI that has is the CAPTCHA. And what do you think, in your opinion? AI is better in solving CAPTCHAs than us or not? Okay, and those who are in the favor of AI. Okay, and those in the favor of human? 50-50. Okay, so according to a few surveys that I read, human have the accuracy of around 80 to 85% in solving the CAPTCHAs, and AI has more than 95%. And perhaps there are people like me who are reducing the accuracy of human because I'm never able to solve the CAPTCHAs. And finally, I'm going to end this talk over here, slightly off topic. But if AI is working as an offensive force and as a defensive force in the domain of web scraping, then I think in the near future, people would like to hire AI nerds rather than very muscular or hunk military forces. So with that, I come to the end of my presentation. And that's about it.
Right. Thank you, Zia. I can tell you're an educator and an experienced person.
Thanks.
Studying. I'm pretty sure many more people will subscribe to your courses after this one. All right, and we start getting some questions. So the first one is, when applying vision versus LLM-based approaches for scraping, what trade-offs do you see in terms of accuracy, scalability, and cost?
In terms of accuracy, I would say computer vision is better if you have some static visuals. If the semantic meanings are not involved, then computer vision performs better. But if there are some semantics involved, for example, if there's a price colon and then the price, and it is replaced by let's say money colon the price, maybe we will have some problems when computer vision is there, but LLMs will be able to solve this problem pretty much easily because they can work with the large language or natural language. About scalability, um, again, you will have many problems when you'll be scaling computer vision models because they are static. If the UI changes or your requirements changes, you'll need to retrain them again. On the other hand, large language models are pretty much generalized. And the last one is the
I think
cost.
cost, yeah.
Yeah. So obviously the 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 computer vision approach seems to be less because that's one-time cost. Once you've trained it, that's free. Rest of the testing and all the predictions are free. On the LLM, you will be feeding the whole DOM object, a lot of tokens. Yeah, that can be a bit costly.
Okay, next question. How effective are AI web scrapers at bypassing AI-based anti-bot detection tools?
How accurate? Sorry.
Yeah, how effective are AI web scrapers at
Mm-hmm.
bypassing AI anti-bot detection tools?
Yeah, I mean, I presented multiple techniques that can be used um, for scraping using AI. Some of them, like the VN model, especially where you're not gonna go towards the DOM at all. You're simply gonna stay away from the DOM. So they are pretty much accurate. But when you start manipulating with the DOM and then things like that, then it is there's a slight bit of problem. But it is kind of a war. The defensive AI is getting stronger, and offensive AI is also getting stronger. But I think defensive AI is a bit lacking because if there are a lot of captchas, the user experience will be ruined. So they don't want to put a lot of security over there as well.
Yeah.
So yeah, I think they're pretty much better. And in near future, we are gonna see the exponential growth over there. Yeah.
Okay. Yeah, and the follow-up question to this from another person: how far are we from self-reliant AI models who could scrape the data autonomously with no manual human input?
I think we're pretty much far away from that. I mean, AI will replace human. There can be an argue on that, but it can surely reduce the workforce. There should be no argument over there. So there's a very famous thing to say: Will I be replaced by AI or not? Well, if I will be replaced by AI or not. It is arguably, I mean, people will have different arguments, but I will surely be replaced by someone who knows how to use AI better than me. Thanks. So, so that's the thing. I think the need of human will always be there, but it will be reduced to slightly to very significant level.
Yeah, for sure. Um, all right, next question. Um, Pretty complicated one. Do transformer-based architectures outperform traditionals RNNs or LSTMNs? I have no clue what that means. I hope you do. For sequence modeling for DOM trees, and what trade-offs have you observed?
Transfo- yeah, yes. Transformers generally do great. They do generally better than RNNs or LSTMs, but I think that's not a fair comparison, honestly, because it's like whether you want to hire Tom Cruise or a local artist. What's the difference? The budget. So,
Okay.
so Transformers, in easy words, Transformers have complex model, but they can retain more memory. On the other hand, LSTMs are lighter, they are quicker, but they cannot retain a lot of memory. In short, so if you can afford complex architects, if you have a lot of data, just go with transformers. But if you're going to run your models on the lighter machines like mobile phones or something where processing power is a significant thing to you, then I think LSTMs will do better jobs because they require a small amount of data as well.
Okay, then another one. When you talk about AI resolving captchas, are you referring to having an active model resolving them or using constructing a captcha solver with AI?
Whatever task you want to perform with the AI, you have to specifically train AI for that particular task on that specific data. So yes, training AI on for that specific captcha solving task is the thing to do. But now we have seen AI generalization where we have different AI models collaborating together. So in short, you can say there can be a module of AI that can be dealing with captchas, and the same AI with another module will be doing some scraping or other tasks.
Okay. Another question related to computer vision. If I can access the page, I can just take the page source and process it. Why would I bother with image processing? Explain the purpose there a bit more.
Sure. Well, they are just different techniques in order to bypass a few things that can bother you if you're working with LLMs. You can surely go with DOM object, DOM node classification, or sequence models, but there are some limitations to that model in terms of accuracy as well. So if you want to go with something like bagging and boosting techniques, where you want to go with a vote of democracy, you need multiple models over there. And again, with the static websites, it tends to be computer vision that outperforms the general LLM models.